Okay. So, the test outline. What I did was I also uploaded an organizer for you guys. So in the weekly calendar, I think it is, I uploaded like an organizer of the test for you. So that I'll just kind of, I'll go through the outline with you guys with the organizer. So I'll kind of show you guys how to use them if you haven't, things like that. Okay, question number 1 on the test is accumulation of change. And it feels like this was forever ago, even though it was just like 2 weeks ago. And absolutely, you guys can just butt in at any time to ask questions. Otherwise, I was just going to kind of go through all the different questions on the test, but absolutely ask away if you have a question on something. So the first thing on accumulation of change is most people forget what this topic even is. And the accumulation of change question is you're going to have some sort. Oh, that pen won't work. Let's undo that. The accumulation of change question of the test will be a graph of some sort. Whatever it looks like. And it generally is going to be time on the bottom. And the side, the y-axis generally stands for just almost anything. Frequently it's velocity, but it could be anything you want. So let's say this one's velocity, and that would be meters per second. So this time would be seconds. And the question is going to ask you, like, what would be the total distance traveled from 2 seconds to 7 seconds? So what you guys would do is you would use the graph you were given, because the graph would be on the test. I already forgot what number I said. I think I said 7. You would find the area of the picture from 2 to 7 seconds. And then that would be your answer. It's going to be some sort of geometric shape. Where did you say you'd be able to see this recording? The recording, I always post the recordings in 2 spots. I post them in the resources folder, and I post them in the daily folder. So it's usually in both spots. Yeah. Okay, so anyway, that's the accumulation of change. And that's very straightforward if you know what you're looking for, And so if you guys are creating organizers, you generally want to write something in this box that would help you answer that question. This one's kind of difficult to write little bullet points about. And so, often you could even just kind of write somewhat of a sample type question that would remind you of what you're supposed to do. Question 2 on the test is a left or a right Riemann sum from a graph. And so if you guys remember what Riemann sums are, that's estimating area with rectangles. So, so you have like a parabola or something. I can't remember if you were given the function on the test or if you're supposed to estimate from the numbers. But either way, so it's very similar to question number 1, except for on question 2, you're going to have to create rectangles. And if it is a left endpoint, then the rectangle you create would be created from the left-hand side of the rectangle. And you will be told how many rectangles you need to make and, from here to there. So left Riemann sum, you use the left side of the rectangle. for the height. Right Riemann sum, use the right side of the rectangle for the height. Is there anything on Riemann sums that you guys might want me to talk about that maybe you can't remember? Like I said, some of these questions feel like they were forever ago, even though it was this unit. Okay. And then you'll also see that on each question, I said what type it will be on the test. So on the test, like say for question 1 and 2, you are literally going to be typing in a number as the answer. And I usually get people asking me if you have to put labels or not. I believe within the question, it usually is phrased to let you know if you're supposed to or not, but on a number short answer, you generally wouldn't because I'm grading the number. But I go through and look at your answers afterwards anyway, just to double check if there's an error for correcting. Okay, question 3 on the test is very similar to question 2, except for you need to use trapezoids. And then the other big difference is that you don't have a picture. You're going to have a table. So let me just make up a random table, and we can talk about how to do trapezoid from a table. So you'd have to have x and f of x. One, two, three, four. Now, because I have 4 boxes, this kind of means that I can only make 3 trapezoids. Because if you guys kind of think of a graph, if you have 4 points, however those 4 points make, you're only going to be able to make 3 shapes from it. So the number of boxes in the table tells you how many trapezoids you can come up with. And whatever these numbers are, 3, 5, 9, 6. Sure. Now, if you guys remember on the trapezoids, the area formula for trapezoid is 1/2 base 1 plus base 2 times height. On a function like this, on a function like this, the height is technically how far it is between the bases. So this would be the width of the rectangle, or trapezoid. Base 1 and base 2 are going to be the function values on the left and on the right. So our first trapezoid would be from 1 to 2. I'll try to color code it, see if that makes it easier to look at. So our first trapezoid would go from 1 to 2. And so the area of that first trapezoid would be 1/2. Base 1 is 3. Base 2 is 5. And the distance between 1 and 2 is 1. So that'd be our first answer. Our second trapezoid would be 1/2. Base 1 is now 5. Base 2 is now 9. Width between them is 1. And I guess pink. Yeah, that shows up. Our third trapezoid would be from 3 to 4. So that would be 9 plus 6 times the distance between 3 and 4. And then you're going to add up all of your areas. This is all one word. Make it a hashtag. Add up all the areas. So like in this instance, we would have 3 areas to add up, and then the size of the table tells you how many trapezoids you'd have. Otherwise, it most likely says in the directions anyway. I don't know. Any kind of questions on the 3 so far? Okay. Summation notation. This is where you definitely have to rely on memory here. The different types of questions you're going to have. So this is the simple summation notation. So like you'll be given a formula like the sum from n equals 1 to 5 n squared plus 1 divided by 3. Okay. And this is a multiple choice question on the test. So what it's going to ask you is what would be the terms that you get from this summation notation. And so that's all you're going to have to do for question 4. And if you guys need to remember, you basically plug 1 in place of n first, then 2, all the way up to 5. So that's regular summation notation. Question 5, writing a Riemann sum with summation notation. I'm not even going to pretend to have these memorized. In your organizer, what I would do is I would write down the formulas. So the formula for left summation notation. Left Riemann sum, written as summation notation, is the sum from 0 to n minus 1 of b minus a divided by n. This is the width of each rectangle. The height of each rectangle is f of a plus b minus a over n I. Right? Right is very much exactly the same, except for on the sum, you go 1 to n instead of 0 to n minus 1. So the main thing is knowing these formulas. Other than the formulas themselves, you basically have to remember what A stands for, B stands for, and N. So N is number of intervals. A, beginning of the intervals. B is the end of the intervals. And then obviously F is the function that you're given. Now this one's multiple choice as well, so you're basically just going to have to pick the correct formula that fits your situation. You do not need to know the midpoint formula, no. So the midpoint formula, I only gave that to you guys because it was in the Khan Academy homework, but the midpoint formula is not part of the AP test. So you only have to know left and right. And midpoint one is even worse because this formula itself is even different. And I think that's why AP doesn't want you to learn it or make you learn it, because these two formulas are the same, you just change the bounds. And then question 6, again, multiple choice, but it goes off of question 5, is writing a definite integral as a limit of summation notation. So if you guys remember, a definite integral is like an infinite number of rectangles. And so the one difference is that you're going to have the limit as the number of rectangles goes to infinity. And then, oh god, that was a bad E. Let's do that again. So it's just as bad. We'll just stick with it. It doesn't matter if you use left or right. So I traditionally just use right because then you can put infinity on the top. But it's the same formulas. You just have infinity for the number of rectangles. But it could be left or right. So do know that because this is multiple choice, it could be either one. You get the same answer either way. So, but A stands for the same, B stands for the same, N is just infinity instead. And then F is the same, whatever function you're given. Okay, so there's the first 6. I don't know. Does anybody want me to talk about anything from this first page? Okay. Are you guys pretty much just here to kind of write down stuff or to soak in info type thing? I mean, I was happy to answer questions if you have them. I just didn't know what you guys wanted out of this. Accumulation function from a graph is, yep, absolutely. You're welcome. You got it? Okay. And then, don't forget, I'm recording all of it, so, if there's something you forget later tonight that you want to look back on, you're absolutely welcome to do that. Number 7 is awfully similar to number 1. The main difference is when you're talking about this accumulation function, you're actually going to have an accumulation function. So, like this will say the integral from 3 to x, and the function itself is the picture, right? So the picture part would be the same. I'll just draw similar to what I drew on the other time. So everything else is the same for the setup, except for once they give you this accumulation function, then you'll be asked to find, this should say f of t. You'll be asked to find something like g of 8. And if, what's great is trying to spell something with wrong letters. So if you're asked to find g of 8, then that would tell you to do the integral from 3 to 8. And so on the picture, then you would find the area from 3 to 8 or wherever it is. So this is basically like a more advanced accumulation function of number 1. But same idea. You'll just be told what numbers to go to differently. Number 8, accumulation function, second fundamental theorem of calculus. So the second fundamental theorem of calculus part of this directions tells me that we will be doing the derivative of a definite integral. Now, the actual formula for this looks terrible, but if you guys go back and look at the questions for this, they're fairly easy. So if you're taking the derivative of an integral, of a definite integral of this setup, you're going to take whatever function, there we go. You're going to take whatever function is there and put it in place of both t's. So your answer would be g of f of x times f prime of x. So like an example, the example would be find the derivative of the integral from 3 to x squared of, I did not look at the test, so I hope I did not make it similar. I'm just making up a random problem here. So if you're asked to find this one, you would take whatever function is here, in this case x squared. Screwed up. This has to be a different variable. It's usually a t. You're going to take whatever function is on top and put it in place of that variable. So this answer would be sine of x squared times 2x. So that's the second fundamental theorem of calc. Oh, my bad. I should have read ahead. Let me pretend that I said all of that for question 9. Because question 9 says second fundamental theorem of calc with chain rule. Question 8 is supposed to be an easier fundamental theorem of calc. So I'll re-example number 8. Negative 20 to x of square root of t squared plus t dt. So if it's just a plain x, then your answer is very straightforward, and you put an x instead of a t. So if you don't need chain rule, it's just a plain x. Chain rule would mean that you have a separate function. Okay, 10. Making appropriate calculus-based decisions from a graph. So we did this in class, and it was a section in Khan Academy. If you guys want to practice, the whole reason I like to put titles on what type of question you're going to have on the test is, like, say you look at number 10 and that title makes no sense to you, then you can go to that section in Khan Academy and practice more questions like that. So making appropriate calculus-based decisions from a graph, this is going to be a hard one for me to come up off the top of my head though. I'm trying to remember one we did in the notes. I think one we did in our notes was something like this. And then I think we were told g of x shoot, now I'm trying to remember how it was written in the notes. I think g of x was written like the integral from 2 to x of f of t. This would be t instead of x, I guess. I believe that was the style we did in our notes. And then it would ask you, is C an inflection point? Something like that. And obviously this question could be completely different. And so I just want to go through with you what calculus-based decisions mean. So if you're asked if C is an inflection point, then that means you need to, in detail, go over what an inflection point is. And it's still multiple choice, so it's not like you have to worry about the wording. So inflection point to me means that I know I have to look at the second derivative. Okay? And so g of x was this integral thing. G prime of x would be the derivative of the integral, which would be f of x. And then g double prime, which is what we need to look at, would be f prime of x, which in our case, our picture is, it was x. Our picture is f of x, right? So if we have a picture of f of x, f prime would be the slopes of f of x. So I'm basically trying to figure out my answers according to the information I'm shown. Well, the slope at C is 0. So that would make C a possible inflection point. So C is a pip. And then to determine if it is an inflection point, I need to look at the slopes before and after C. So slope before C is negative. Slope after C, positive. So then those three pieces of information tell me that C is an inflection point of g of x. And that's because, according to the picture, g double prime is equal to 0 at C. G double prime is negative before, G double prime is positive after. So what I'm writing in purple is calculus-based justification to make a decision. So that's kind of what 10 is going to be like. And obviously these can be so very different from each other. It's just that you have to know how to find critical points, critical numbers, relative max, relative min, inflection points. You have to know the details of all of those to be able to make appropriate calculus-based decisions. And it's not bad. It's things we've done. It's like nothing new. 11, evaluating a definite integral from a graph. Well, a definite integral, you guys kind of know by now, is represents the area, the exact area under the curve. And so number 11 is going to be exactly like question 1 and 7, because this was technically before we knew how to evaluate integrals. So the graph you're going to get is going to have, geometric shapes. So like pretend that's a semicircle. Okay. And you might be asked to find this area. And the one difference between 1 and 7 and 11 is question 11, now that it's called a definite integral rather than area, is definite integrals would have positives values and negative values, and so you'd have to combine them together. But it will be geometric shapes for you to be able to find the area. Evaluating a definite integral using properties. Okay, so this was the style question where you might be told that the integral from 2 to 4 of f of x is equal to 8. And you might be told the integral from 2 to 4 of g of x would be 10. And you might be asked to find the integral from 2 to 4 of 3 f of x minus 2 g of x. So by using properties, you would know that the subtraction means we can evaluate them separately, and you would know that the times 3 and the times 2 can be done separately. So this is as simple and straightforward as 3 times 8 minus 2 times 10. And it could be from any of the properties we learned. So it could be from adjacent properties together, or adjacent areas together. It could be from the integral from 2 to 2. It could be from, you might have to reverse the integral boundaries to give a negative answer. So it's just all the different properties. 13, evaluate a definite. Are you guys, I don't know, you guys have any questions at this point? I definitely can. Mm-hmm. I was going to say, isn't that what number 12 was? Yes. So 13 is same as 12, just probably a different property. Finding an indefinite integral. So if you look at 14, 15, and 16, they're all the same style question. And we learned multiple ways of doing indefinite integrals. So this is where you need to make sure to know how to do power rule. You need to make sure to know how to do natural log integration, so the integral of 1 over x dx is natural log. 3 was e. 4 and 5 were trig. So these 5 styles of integration are obviously going to be question 14, 15, 16, 17. 17 is multiple choice, but nonetheless. Now, the only difference that can be part of these is, each question doesn't have to be only one. Like, you could absolutely have a question that has multiple different things in it. So, you might have a question that says, find the integral of 2 sine of x minus x to the negative 4, plus 1 over x, something dumb like this. So this type of question, you would have to know that each one of these 3 is different. Let's put a 5 there. And then also needing to know properties, like the multiplier of 2 and the multiplier of 5 don't affect the integration. They just are going to be multiplied on the integration. So that's these 4 questions. I want to say they're straightforward. It's just this is what we've been doing all week. So I'm sure you guys are probably a lot more familiar with this because it's newest in your head. And then question 18 is finding a definite integral. And a reminder what a definite integral is if you are integrating from a to b of a function, your answer would be the integrated equation, plug in b minus plug in a. And again, we've been doing that these last handful of days, so it's probably fresher in your head. And you would integrate with power rule or natural logs or e's or sines or cosines. And 19 and 20 should be really fresh in your head since we did them today. So I don't think I need to put anything up here because we talked about it in class today. And 21, we did at the end of the hour today. I'm going to leave it on the test, but it's worth 0 points. So you are welcome to do it if you want, just to see if you can get it right, but it will not count against your grade, right or wrong. Okay. Well, those are the questions on the test. Do you guys have anything you want me to go through with you? Anything you're having trouble with individually? Because yeah. 8? Yeah, definitely. 8. Oh yeah, that was the one that I did 9 for on accident first. Yeah. Anybody else? I mean, I'm basically just here to answer your questions. I'm not obviously I'm not going to give away info about the test. I just wanted to help you guys out, help you feel more sure about yourself. Okay. Do you want to be done here? I'll be honest, I thought there was going to be more than 6 people here. But I also know that Calc Rex, it has a toll on your brain. Like, you pretty much have a time limit each day on the amount of calc you can do. Okay, I'll stop the... Oh, go for it.